Today, we're going to run a tap to a part. So we're going to use the vertical mill. We're going to find our location with an edge finder, just like before. And then we're going to set up, we're going to drill a hole, and we're going to tap it. So we got the edge finder, we got the readout, we got the milling machine. So the first thing we're going to do, pull down the oil handle, hold it for a second or two, and let go. We're then going to make sure the axes lock are off. So all these are loose, 1, 2, and 3. If you're driving this thing around with any of the handles, and it feels like it doesn't want to turn easily, well, you got the lock on. So take the locks off. So we're going to use an edge finder just like before. We're going to touch off an edge, we're going to zero the readout, we're going to come in the radius of the edge finder, and that's going to find our left edge on the x-axis. For y, we want to find the center of the part. So this is a little bit different. We're going to touch off, we're going to zero it, we're going to ignore the radius, we're going to touch off the other side, and we're going to divide by 2. I'll show you that in a second. So I'm going to come in until the edge finder kicks out, just like we did last time, and we can get fancy and we can give a little tap, make sure it's running out. And as we come in, it's going to run out less and less, and then it's going to kick over. And what I'll do is I'll turn the machine in reverse so you can see that easily from where the camera is. And kicked over. So I'm going to go ahead, I'm going to zero my X, I'm going to come up, I'm going to come in 0.1 inches. Now the reason for 0.1 is that it's half the diameter, that's the radius, of the edge finder. And I'm going to re-zero. And I'm going to physically look at it. Does it look like it's centered over the part? And the answer is yes. A lot of students will crank 0.1 inch the wrong way, and there'll be a gap. They won't bother to take a look, they'll zero it, and they'll go back to work, and the part will be wrong. But here I am, I'm going to recheck. That looks centered by eye. I go up on the readout, I'm 7 thousandths off. Well, that's as good as I can work by eye. So now I'm over the edge, I'm good to go. Other axis, I'm going to come in, I'm going to touch off, and the readout, the edge finder is going to kick out. I'm going to zero Y. I'm not going to worry about the radius. I just zero it against the diameter. I'm going to come over, I'm going to come down, and it's going to kick out. Now I have a 1 inch part. It just kicked out. I have a 1 inch part and I have a 0.2 inch edge finder. So if I look at the math on this, if this is 1 inch wide and I zeroed against the edge and I didn't worry about the radius, that put me 0.1 inch away on that side. I came over the other side of the part, I kicked out. I didn't worry about the radius. I didn't zero it either, but I added 1 inch plus 0.1 on the right, 0.1 on the left for where I'm standing, in other words 0.1 on the back, 0.1 on the front, 1 inch on the part. It should say about 1.2 on the readout. And sure enough, I take a look and I have 1.206. So I measured the part using the edge finder. So if I were to subtract the edge finder's diameter from that reading, I'll get the size of the part. So the part's 1 inch plus a couple thousandths, because there's always tolerance on manufacturing. I get a part just over an inch, and that's what I'm showing. So I'm going to take my reading, 1.206, and I'm going to divide it by 2. And I'm going to crank to that location. So 1.206 divided by 2 is 0.603. I'm doing this in my head. There we go. I'm not going to worry, that's close enough for that. And here we are, I'm at the center of the part. I'm going to come in 1 inch on X, I'm going to leave it's centered on Y. And drill my hole. So now that I'm on location, make sure it doesn't move, I'm going to lock the axis and I'm going to unlock it when I'm done. Alright, I have a center drill, I have a number 7 drill, and a 1/4-20 tap. Now, in this video I'm not going to talk about selecting the proper drills and taps, that's a separate video, but the print calls out a 1/4-20, so it's a 1/4 inch diameter, 20 sharp points in 1 inch. This is a standard inch series specification, and a 1/4-20 bolt is the most common bolt in the United States. So I got my tap, this will actually cut the threads, but it won't cut from solid. I have to drill a hole first. Now, I don't use a 1/4 inch drill for a 1/4 inch tap because, well, this is 1/4 inch OD. If I drilled it a 1/4 inch, the tap would fall through, wouldn't touch anything. I have to have it undersized. That's not a random number. There's an actual calculation. I don't bother to show it. I just show you on the chart. And the correct tap drill size for this tap is a number 7, which measures 0.201 OD. Now the center drill I chose because it's a little bit bigger than the final bolt size, and I want to have a little chamfer on the hole. And I'll show you this on the board in a minute. Now, why center drill? Well, if I just drilled this with nothing, it would hit the flat surface and it would wander around, it would walk. This makes it go where I want. Put the center drill in, tighten it, and center drills always need a drop or two of oil. What's going on here? Well, I tightened the drill up on the sides of the jaw, but I didn't tighten it with the chuck key, I tightened it by hand. So I didn't damage anything, and I looked at it before I turned it on or tightened it further, and that looks wrong. No problem. Loosen it, wiggle it around, shift it to center, tighten by hand, spin it, looks true. Tighten with a chuck key. Drop the oil down in the cone. Now, see the chip coming off that long string? The chips are breaking now, but if it was coming off as a long string, I would just back out, and that would break that chip. So here we go. We have a hole. It's chamfered on top. The hole is through the part, which is what the print called for. And there's my tap. And I can even verify, which we may not be able to catch on camera, but it says 1/4-20 NC, which stands for National Course. I'll explain that in another video. Now, I could hold this in the drill chuck, but it's really easy to break a tap this way. This is called power tapping. I'm not going to do this. I'm going to put a pointy center in the drill chuck, which happens to match a cone in the back of the tap handle. I'm going to crank the knee down. A little bit of oil. I'm going to hold the tap and the tap handle. The tap has 4 flats. It has a square cut in the end. That matches a square inside the tap handle. This is what actually holds it. So I'm just inserting it enough for that square to mate up with the handle. I didn't insert it all the way and clamp on the round. It's round. It will not clamp well. I've seen people clamp on the round, have it slip, get a pair of pliers and tighten this up, and it breaks the side of the tap handle. This is what it's for. All right, so here we are. Finger tight, that's all I need. Point in the back. I'm going to apply light pressure with the quill to run that point down. I'm not going to force anything. And I'm going to turn the tap by hand and keep the quill on it with light pressure. And every so often, I'm going to back up and break the chip. Remember, this tap is cutting a helical groove on the inside of the part. It's making V's, and in the process, it's making chips. This is a pusher tap, otherwise known as a gun tap, and it pushes the chips ahead, so it tends not to clog up. There's another style, which is a standard 3-piece kit of taper, plug, and bottom tap. They store the chips in the flutes, and it jams up. They really need to be backed up every couple turns, back it up half a turn to a turn. So I'm going to run this down. I'm going to go pretty far because it's a through hole, but realistically you need about 4 to 8 threads in the work. This is going to be way more than that, but I'm just going to go ahead and do it. And I'm going to back up. If it feels like you're forcing the tap, stop and get an instructor, because you're probably going to break the tap off. Taps are expensive and they're also very, very hard. So if you break it off in the work, it jams in and it can't be extracted. And if I got lucky, and it looks like I did, the chamfer I put in from the center drill is just a little bit bigger than the size of the tap, so I have a little chamfer on top of the hole. And this will help the bolt start and not cross thread.